Welcome back to the MEV series. Last time we arbitraged 2 exchanges and made a real profit, but we needed $50,000 of our own to do it. Today we do the exact same trade with zero capital by borrowing the money for a few microseconds with a flash loan and paying it back in the same transaction. This is the upgrade every real searcher uses. Let's build it. Okay. Here's the magic. A flash loan lets you borrow any amount with no collateral at all on a single condition. You repay it plus a tiny fee before the transaction ends. If you don't, the entire transaction reverts, as if the loan never happened. So the lender can never lose, and it means you can wield millions of dollars you don't actually have for the length of one transaction, risking nothing but gas. The plan on one screen, our searcher holding nothing does 5 things in one transaction. 1. Flash borrow USDC from Aave. 2. Buy WETH cheap on Uniswap, where a big trade just made it cheap. 3. Sell that WETH dear on SushiSwap. 4. Repay of the loan plus its fee. 5. Keep whatever is left. The gap between the 2 exchanges minus fees is pure profit, and none of it started as ours. Let's build it in Foundry against a real fork of Ethereum so it trades on the actual Aave, Uniswap and Sushi. Here's the config. Now to the contract. Our lab is the same private fork of mainnet as before. So it already has Aave's liquidity and the real Uniswap and Sushi pools. That's what lets us borrow and trade for real without spending a cent. We start with the skeleton, 3 tiny interfaces so we can talk to tokens, to the swap routers and to Aave's flash loan plus Foundry's console so our contract can print its own balance as it runs. Then the contract startArb with the token and pool addresses straight from mainnet and 3 empty functions. startArb to kick it off, executeOperation which is Aave's callback and a small swap helper. Let's fill them in. First, startArb. It's one line. Ask Aave for a flash loan of USDC. Aave hands us the money and immediately calls us back at executeOperation. Everything interesting happens inside that callback while we're holding the borrowed funds. That callback is the whole trade, and this time we print our balance at every single step so we can watch the money move. We now hold the borrowed USDC, so buy cheap WETH on Uniswap, then sell that WETH on Sushi where it's pricier, ending back in USDC. Then we approve Aave to pull back the loan plus its fee. Between each step we log the balance, what we borrowed, the WETH we bought, the bigger pile of USDC we sold it for, what we owe Aave and the profit left over. We return true, and that leftover USDC is pure profit, made with money we never owned. To helper we called twice, given a router, an input token, an output token and an amount. It approves the router, builds the 2-step path, does the swap and returns how much came back. One clean function used for both legs of the arbitrage. Before we run it, let's read the test, so the numbers actually mean something. Up top we pull in Foundry's tools and our ARB. The setup forks real mainnet at a fixed block, then hands a whale 500 WETH and has them dump 300 of it onto Uniswap. That dump is what makes WETH cheap on Uniswap, and it's the price gap we're going to exploit. Then it deploys our ARB holding nothing at all. The test itself is short. First it proves our contract really starts with 0 USDC, then it calls startArb with 50,000, the one call that borrows, trades and repays, and finally checks we ended with a profit. Let's run it. Run it, or and read the ledger of our contract printed line by line. We start with $0. Then inside one single transaction, step 1, we flash borrow 50,000 USDC, and there it is on our balance. Step 2, we spend all of it buying WETH on Uniswap, about 13.5 coins. Step 3, we sell that WETH on Sushi and come back holding 51,300 USDC, more than we started with. Step 4, we owe Aave the 50,000 back plus a $25 fee. And step 5, once that's repaid, $1,306 are left over. That's the profit, and our end balance confirms it, 1,306 from a start of exactly 0 all in one transaction against the real mainnet pools. Two things make this huge. You need no capital, so the barrier to entry basically vanishes. Anyone can attempt any arbitrage. And it's atomic. If the trade doesn't profit, the whole transaction reverts and you lose nothing but gas. You literally can't lose money on the trade. That combination is exactly why the public mempool is a war zone of bots, all racing to land these transactions first. Quick recap. A flash loan lets you borrow anything as long as you repay it in the same transaction. You wrap the whole arbitrage inside the loan's callback. Buy cheap, sell dear, repay the loan plus fee, keep the rest. Zero capital, fully atomic, and the only thing you can lose is gas. That's the tool underneath a huge slice of on-chain MEV. A quick note, this series takes real work to produce, reproducing each strategy safely and clearly. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next episode. Thank you. FTZ, that's flash loan arbitrage, the searcher's power tool. Next episode, MEV, that targets you directly, the sandwich attack, where a bot buys right before your swap and sells right after, pocketing the price it pushed you into. Subscribe so you don't miss it, comment the strategy you want next, and I'll see you there.